Right, we want to find the derivative of the function f of x, which equals the trigonometric sine of x. How do we go about doing this? So we first write down the formula for the first principles of differentiation, and this is the limit as h tends to 0 of f into x plus h minus f of x all over h. So that which is f primed of x, and this is the limit as h tends to 0 of the trigonometric sine of x plus h minus the sine of x all over h. Right, it has already been done on the left of the screen, but I'm trying to explain these here so that we have the limit as h tends to 0, and then you have the trigonometric sine of x. Using compound angle formulae, the sine of x plus h is the sine of x cosine h here. Okay, so this one is cosine h. Then you have plus cosine x, the sine of h, minus the sine of x all over h. And this is actually f primed of x, which is exactly the same as what? Right, so we group some like terms here, and we obtain the limit as h approaches 0. Right, so we factor out the trigonometric sine of x, and if we do so, we are left with from the first term and the last term. So we're left with the cosine of h minus 1 upon factorization by the common factor sine x plus cosine x times the sine of h, and this is divided by h like this. Okay, so this is what we get. This is exactly what we get. So when we continue, we get f primed of x, and what is all these here? So we separate the two things here. They're in the numerator, and this becomes the limit as h approaches 0 of the sine of x. We group the h terms together, so you'll have the cosine h minus 1 divided by h. Then we have cosine x, which is the sine of h over h. So we have this. So you have f primed of x. Now you separate the two terms, opening the limit up, opening the brackets or the parentheses up, and this leads to, you take out the common factor. The common factor here is actually the sine of x. So you have the sine of x, and you have therefore the limit as h tends to 0 of cosine h minus 1 divided by h. And then now you also take the limit of the other expression, but taking out the common factors, or rather the constants. So here a constant is a function that is not of h, because the limit is the limit as h tends to, meaning you have the sine of h over h that is actually a variable. That is actually a variable. Okay, we continue, from which we're able to obtain this one here, the sine of x. Right, if you take the limit here in the cosine h minus 1 over h, it becomes 0 over 0, because cosine 0 is 1. So you have 1 minus 1, which is 0 over 0. And that means you have that this is undefined. So you need to multiply by the reciprocal, and this is actually, you can multiply by cosine h plus 1 divided by cosine h plus 1. And then here you have cosine x. And then here you have the limit as h tends to 0 of the trigonometric sine of h over h. Okay, so you have this limit here. Okay, and we continue with the evaluation, upon which we obtain that this is the sine of x. Right, times the limit as h approaches 0. And then the top is cosine squared h minus 1 divided by h into cosine h plus 1. And then this is exactly cosine x. Okay, in mathematics, the limit of sine h over h is the same as the number 1. Okay, you can prove that one, but yeah, it is 1. And then we continue with f primed of x, which is the limit, which is exactly the sine first. So we have the sine here. So this one remains the sine of x. And then you have the cosine squared. What is the cosine squared? That one we know from what we call the Pythagorean identity from the metric syllabus. If you factor out the negative in the numerator, we have therefore 1 minus cosine squared of h. We divide everything by h into cosine h plus 1 plus cosine x plus cosine x, like this, which is just you can just write here cosine x. You can just write cosine x, okay? And you have cosine x. Right, in the numerator now of this expression, we already have the Pythagorean identity, the squares identity for the or in the numerator. In which case, therefore, we have the limit as h approaches 0. What is 1 minus cos squared? Is sine squared. So that's minus sine squared h. Divided by h into cos h plus 1 plus cosine x. F primed of x. We have the sine of x. What is minus the sine squared? So this is the limit. So this becomes minus the sine of h over h. And now, what do we get out of this here? So this one here is exactly the same as there's another sign that is going to appear on the other side. So you can break these down to the limit as h tends to 0. Then you have the sine of h over cosine h plus 1 plus cosine x, like this. F primed of x, which is the sine of x. So what is sine h over h? Right, we said it is 1, but obviously it's a negative, so it's going to be a minus 1. And then now here you can just get this one. If you want, you can do here sine 0 for the sine h over cosine h plus 1. You have cosine 0 plus 1. And then you add cosine x, like this. Okay, you add cosine x. All right, you add the trigonometric cosine of x. And now, which is the sine 0 is 0. So by this, everything becomes 0. So we have 0, because sine 0 is 0, the numerator. We agree that the denominator is cosine 0 plus 1. Cosine 0 is 1. So you have this one plus cosine x, and this is cosine x. So as a consequence, what we're getting, therefore, is that this is f primed, which is cosine x. Okay, so what is this? Hence, the implication therefore is that f of x, okay, the implication is therefore that f of x equals sine x actually implies that the derivative or the first derivative is the same as cosine x. And this is the end of this. Okay, so we have answered the question. So if f of x is sine x, then the derivative is, or the first derivative is cosine x. Okay, and this is what had to be shown here. In black, we had this one here, we had the sine x here, and we had the first principles of differentiation. And we're able to find the answer that f primed is cosine x. So obviously the implication therefore is that the derivative of the sine is the cosine. Okay, is the cosine x, and we are done. So thanks everybody, goodbye to you.